So today we are talking about, it's called right triangle trigonometry, if we want to be fancy instead of trig. Trigonometry, which sounds so hard, but it's not, right? It's not hard at all. Okay, so let's set up the ratios. So to do the ratios, we're going to set up the fractions, okay? Just like we did before. The ratios, a fancy word for ratios means fractions, okay? So there's two angles, and I don't want to do it with both. I just want one or the other. So, I don't know, Gage, pick. What do you want, A or B? It does not matter to me. Which angle do you like? So it is angle A, okay? So once we pick A, then the names of the sides come together, okay? You pick your angle, then the sides have names, right? So that's obviously my opposite. Everybody agree with that? That's my hypotenuse. Everybody agree with that? And that's my adjacent, okay? So let's do it. We've got all 6 of these. We're going to have the sine, the cosine, the tangent, cosecant, secant, cotangent. We can do this, all right? So right off the bat. So the sine of A as a fraction. Well, sine of A, sine, we're not in church. Sine is opposite over hypotenuse, so let's go 15 over 39. You okay with that? Cosine of A. What's cosine equal? It's adjacent over hypotenuse. Good, which is going to be my 36 over my 39. Good. Tangent of A. Okay. What is tangent? It's opposite over adjacent, so it's 15 over 36. Good. Now the next 3 are kind of new ones. Cosecant's the opposite sine, so I'll put cosecant here. I'll put cosecant of A next to sine of A, because then it makes it really easy, right? Because I know that if cosecant is just the opposite sine, that's just 39 over 15, right? We just flip it. So it's just going to be 39 over 15. Secant, I'll put next to cosine, because secant's the opposite of cosine, so it's just the flip of this. I'm going to make that a 39 over 36, okay? And cotangent of A, it's just the opposite tangent, so we just flip that one, and it's equal to 36 over 15, okay? Thumbs up, I want to see it, I really do. I want to see how you're doing, okay? Okay? Everybody? Okay, good. Kasia? Yeah, good. Okay, now, example 2. So find the sine, cosine, tangent from these 2 special triangles. Now, first of all, I have to know something about a 45, 45, 90 triangle. Now, hey, what do you know? There they are, right? There they are. So let me go ahead and put in the x's. So in a 45, 45, 90 triangle, it's half a square. Does that make sense? So that's why this would be x and x, because a 45, 45 is really cutting a square in half. These 2 sides are equal, right? And if you were to do Pythagoras' theorem, this side turns out to be x squared root of 2, okay? So let's do the sine of 45, okay? All right, sine of 45. Well, it doesn't matter, does it? Great question, really good question. Because we're going to get the exact same answer. We should, right? I mean, you agree? So which one do you want to use? The bottom one? How about just the bottom one? It's easier. So what is sine? Opposite, right? Over hypotenuse, right? So it's going to be x over x squared root of 2, right? What the heck? X over x. What's x over x? 1. So the answer is just 1 over the square root of 2, isn't it? Good thing we just finished square roots, because you can't have that answer. That's a bad answer, isn't it? You could have that answer, but I don't like that answer. Sarah, question.
What does this accomplish?
Oh, great questions. Check it out. We're heading towards this thing right here.
What does that test? If we decide to...
We'll give it back. Can I borrow your phone? I will give it back. I promise. I'll give it back in about 2 minutes.
Are we doing that this year?
Okay, ready? Watch. That is connected to this. When you take this and when you roll it, it becomes a wave. And there's lots of applications of waves. This is probably the biggest application we have today as far as waves. So if you are a sound engineer or an electrical engineer, you are programming waves so that when you talk to somebody, the signal travels in a wave to your phone and you can talk to somebody. Now, will you ever use this? Gosh, that'd be great if you did. You'd make a lot of money. You'd make a lot of money, wouldn't you? So, can I keep going? So this becomes really the square root of 2 over 2. And guess what? If you look at this circle, square root of 2 over 2 is on the circle, isn't it? And it's right at the circle at 45 degrees. What do you know? See, there it is, 45 degrees, square root of 2 over 2. They are connected, but I'm going to show you why they're connected in about a couple of weeks, okay? Now, cosine should be the same. You guys agree?
A couple of weeks.
No, we got more than that. Cosine's the same way. Cosine of 45 turns out to be the same answer. Okay? But what about tangent? Squeeze that in. Probably won't get to this one. What about tangent of 45? Huh? What's tangent of 45 can equal? It is 1. It is x over x, which is 1. That's weird. So you mean if I were to use my calculator, tangent of 45 should give me 1? I'll guess. Tangent of 45. Wow, I just figured out something without using my calculator. I am so smart. Tangent of 45 is 1. And it is up there on the unit circle. Okay. The red are the tangent values. In fact, take a look up in the corner. It says tan in red. Yeah, so if you can figure out how to use that thing, it makes the test easy, doesn't it?
Will those be up?
Yep. Yeah. No, I'm going to help you, okay? So cosine is going to be the exact same as 45. It's going to be the adjacent over the hypotenuse, which is still going to be x over x squared, so 2. The x's cancel. And you're left with 1 over square root of 2. And if I fix it, it becomes square root of 2 over 2. You know how I fix it by multiplying by the square root of 2 over square root of 2? Okay, now, how about example number 3? Now, we're going to come back to these, you guys. We will come back to these, trust me. But right now, I just wanted you to see a little bit how they work. Now, how about this one, though? All right, find the missing sides and angles. Okay, let's go through our steps. What's step 1?
Choose a given angle.
Okay, what angle do you want to choose? I agree. You could use P, but let's use 38 since we know it, okay? Never use the 90. You know why you'd never use the 90? Well, not only that, but if you're looking at 90 and you want to get an angle and you want to find out how high something is, could you? If you're right directly underneath, you couldn't do it, right? You need some kind of an angle, right? Okay, so step 2, what's it say? Step 2. Okay, what's my given side? 12, let's circle it, okay? Okay, step 3, what's it say? So we're either going to find little I or little p. It does not matter to me which one. Little I it is, okay? Now, what are the names of those sides? What are the names of the sides? Don't say I and p, but from this angle, that's my opposite. Everybody agree? And that's my, so I've got my opposite and I've got my hypotenuse, right? Okay, so which one am I going to use? Opposite hypotenuse. Look it up there. Opposite hypotenuse. Don't say sin. We're not in church, okay? Sine. Okay, good. We're going to use sine. So it says sine of theta. So sine of, it says sine of theta, but theta is the angle, right? Theta is the angle. So we write sine of 38 equals, and it says opposite over hypotenuse, but the opposite is I, and the hypotenuse is 12, right? So we go I over 12. How am I doing? Of course you get it. You're a smart girl.
Nah, babies. Apply yourself.
Jackson asked me, okay?
I got it.
You good? Okay, what's step 4 say? Oh, we did step 4. Never mind. What's step 5 say?
Cross multiply.
So let's multiply the 12, because times by 12. Let's multiply the 12 right up there, okay? So we're going to go 12 times the sine of 38 equals the lie, right? And then all we have to do is just use our calculator, right? Use the button. Make sure you're in degree mode, right, Carlos? Right? Yeah. 12 sine 38. Oops, 38. Did you guys get about 7.4? We get about 7.4? Thumbs up if you got 7.4. Okay, good. All right, so little I is 7.4. Okay, easy, right? 7.4 for that. Okay, now, I'm not done with this triangle, but the rest of the stuff doesn't take any trig, it just takes geometry. So what's the next step you would do, okay? Do a little geometry. What would be the next thing you'd find?
Add 90 over 7.
There you go. There you go. So Ethan's going for angle P, right? These two angles have to add up to 90. You guys agree? So we'll just go 90 minus 38. How's that, right? Okay, I totally agree with you. So let's go 90 minus 38, and I get 52. Okay, now, I still don't know little p, but I can find little p, right? Pythagoras theorem, you guys agree? So let's add some steps here. I'm going to add step number 6. You say find the other acute angle, and I'm just going to do exactly what Ethan said. I'm just going to 90 minus theta, okay, right? And that's all you did. You just subtract it from 90. Yeah.
Can we just do the same thing that we did for little I?
Yes.
Now that we have that angle?
Yes, in fact, great. I want to show both ways. Okay, step 7 is the Pythagoras theorem, or I'm gonna put it up there. Or I like what Jackson said. You know what? You don't have to do that. You could just find it using cosine. Couldn't you, Jackson? You could use trig all over again. You can go cosine of 38. So you guys know how to use the Pythagoras theorem, but you could have said, well, let's just go cosine of 38 equals little p over 12. Do you want to see what he did? You don't have to do it this way, but check it out the way Jackson wants to do it, okay? He said, okay, if I want to find little p, that's my adjacent side, right? This is my adjacent, my hypotenuse. So he set up cosine of 38, adjacent of hypotenuse. So you can multiply by the 12, right? And then you're going to get 12 times the cosine of 38. Yes. Or Pythagoras theorem, right? Which do you prefer? It does not matter to me at all. You guys like Pythagoras theorem better? It's actually, you use whichever one you like, okay? Okay, how about this one? 4. Can you do it on your own? Okay. Okay. Why don't you guys figure it out on your own? I'm going to give you about 5 minutes, okay? See what you can find, okay? Try it on your own. And I'll stop recording because I think that's all that anybody who needs to see this has done. Well, you need to see the homework. There we go. Okay, and I'm going to stop recording.